So, domain and range. Sorry. Hard to see with the lights off completely. Okay? Because xy is on the unit circle, and x is going between -1 and 1, and y is going between -1 and 1, then our domain is the interval of -1 to 1, and our range is the interval of -1 to 1. Can it be -1 and 1? Yes. So in interval notation, we like to use a bracket, a square bracket, when it can be equal to. So -1 to 1 for our domain, and -1 to 1 for our range. Okay? Now, when we talk about even and odd functions, that's the next part of your foldable. I think, what color was that guy yesterday? Pink on Friday. Forgot to orient. I was surprised when it actually wrote where I thought it was writing, until now, of course, it won't go. Okay? Remind me, what were even and odd functions? Even functions, an example. We've talked about them sporadically through the year. Even functions. What was one of the even functions that we studied? Very beginning. A parabola. Okay. Parabola y equals x squared is an even function, because when we put in -x for the x, we still got x squared, right? So it was symmetric with respect to which axis? The y-axis. Okay. Odd function, cube root, right? John Travolta, okay? Saturday Night Fever, it is symmetric with respect to the origin. Okay, that's an odd function. Y equals x cubed. Okay? Cosine and secant are considered even functions. Okay? The reason they're even is that if we take the cosine of -90 degrees, you're going to get the same thing as the value of the cosine of 90 degrees. The cosine of -30 will be the same thing as the cosine of 30. The cosine of 72 will be the same thing as a -72 will be the same thing as the cosine of 72. And because cosine and secant are reciprocal functions, secant is also an even function. Okay? But odd functions, like the sine, the cosecant, the tangent, and the cotangent, if you plug a negative value in, you'll get the opposite of what it would have been. So the sine of -30 is the opposite of whatever the sine of 30 is. So what was the sine of 30? 1/2. So the sine of -30 would be -1/2. Okay? Sine of 45 is square root of 2 over 2. So the sine of a -45, 315, is going to be negative square root of 2 over 2. Likewise for cosecant, tangent, cotangent. Everybody cool with that? Nothing earth-shattering here. Okay? So, now they want us to find the following. And I believe these are examples on your foldable. Kind of in the middle panel. Cosine of 9 pi over 3. Okay? So the first thing we have to do is realize that radians are nice when it comes to learning or knowing what their values are for those special angles. Okay? When you see 9 pi over 3, simplify it. How many is that? 3 pi. Okay? So we want to know what is the cosine of 3 pi. Okay? So then we think about our reference angles here. If we started out with our initial ray being on the x-axis, putting it in a standard position, and we look for 3 pi, half of a rotation is 1 pi, a full rotation is 2 pi, so we're basically a rotation and a half away. Okay? So far, so good? Okay? What is this point on a unit circle? -180 degrees, and then what's the actual ordered pair for this point on a unit circle? -1, 0. Okay? Cosine is x, isn't it? So what's the x value of that point? -1. Did I lose anybody? Okay? Not seeing any puzzled faces, but maybe you're poker players and you are puzzled. Everybody okay? All right. Sine of -11 pi over 2. Okay? -11 pi over 2. Well, it's cofunction, or we know that it's an odd function, right? So the sine of -11 pi over 2 would be whatever a negative value of the sine of 11 pi over 2. Write that better. But now think about it. When you're dealing with the pi over 2, half a revolution, a semicircle, is pi, right? So a pi over 2 is going to be some sort of a 90-degree angle, isn't it? It's going to be here or here. Okay? So let's do the negative rotation. 11 pi over 2. Here's 1 pi over 2, 2 pi over 2, or pi, 3, 4 pi over 2. Yep. Everybody agree that's -11 pi over 2? Okay, so I'm counting by pi over 2's. Over 2's goes by quarters, and when it's over 4's, it goes by 8's, because there are eighths of them. Yep, they're 45 degrees. Anytime it's over a 6, that's a 30 degree. And anytime it's over a 3, it's a 60 degree. It's one of the half angles, or half semicircles, okay? So this is going to be a 90-degree angle. So if we're going 11 pi over 2, here's 1 pi over 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I went backwards because it was negative. Went clockwise. Okay, so this is 0 over -1. +1, thank you. 0 over +1. Okay, and the sine is going to be 1, the y value. Okay. Then they can say, hey, if the tangent of t is 2/3, what will the tangent of -t be? -2/3. It's an odd function, isn't it? So we change the sign of its value. Even functions keep them the same. Odd functions make them opposite. Yes, sir? Absolutely. Yep. The video is already on the blog, and then I'll put the whole PowerPoint together at today's. Okay, I didn't put the slides up for just the video. Absolutely. Okay, so part A, cosine of 9 pi over 3. Well, first of all, we have to recognize that that's not simplified. Okay, so 9 divided by 3 is 3. So this is the cosine of 3 pi. Okay. Now, pi is a half of a rotation around the circle. Okay, so there's pi radians. Okay, so now we need 3 of those. So that was one of them. Here's 2, and then we go one more time, and now we're at 3. And then we figure out this ordered pair and use the x value. Okay? Any other ones that weren't clear? Okay. All right, these now are asking you to use a calculator. So these aren't ones that we should be familiar with. They're not our special angles. We don't know anything about over 8s, right? And we don't know anything about cosecants of things that don't have pi's in them. Okay? So, calculators out. Make sure they're in radian this time. Radian. Let me bring my calculator up so I can show you. All right, so to get to radian mode, how do we get there? Mode, and then we have to go down to radian. So mode, and then down to radian, and make sure you choose radian and make sure that it is highlighted. So not only highlighted, but you press enter to be on top of it. Okay, so now I'm in radian mode. I want to take the sine of 3 pi over 8. So I'm going to quit this mode and do a 3 times pi divided by 8. Pi is the shift of your caret key. And I get 1.17. Now I want the sine of that. So I click sine and then second answer. So it'll pull up the previous one. Okay, sine is right below apps, right below the blue button. And then when I want the answer, I just go to second and choose the yellow thing above the minus sign. Okay, it keeps the last thing that was in memory for you, and to get to the answer, it's the shift of this little minus sign here. Okay, so that will save you from having to retype it in. Okay, so sign of answer, when we press enter, we get 0.9238, so 0.924 is to 3 decimal places. That's your answer. And I'm way off because of the magnifier. Okay? Yes, sir. So yours is different. Everybody get that answer? If you didn't get that answer, let's make sure we get it right. All right, so you need to be in radians, and I can't tell which ones you're in right now. Let's find your engineer. There's your degree, I think. So do a, yeah. So make sure you choose number 2. Okay, so that's degrees. So we want to actually be in radian mode. So I'll come back and find it. It might be under motor setup. Okay. All right, so we want to make sure that we get the same answer on this one. Okay, here we go. Cosecant. Do we have a button for cosecant on our calculator? No. Reciprocal of sine. So we're going to use this to the -1 power. Okay? Same thing. In radian mode, okay, so we don't have to change anything. We want the cosecant of 3. That means that we're finding the sine of 3, and then we're going to flip it by using the x to the -1 power. Okay? So sine of 3, down here. So find sine of 3, and then once you have that answer, do the 1 over button, or x to the -1 button, depending on your calculator. 7.086. So 7.086. The 1 won't make the 6 change. Okay? Everybody get that? Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Secant and cosine. The C's and S's don't match up. 1 over sine. Okay? Always tangent. Yep, 1 over tangent. Okay? All right. All right, so this was the assignment. It was supposed to be page 277. I put it in 2 places, the wrong place. Okay? So try to finish that one up. That was the assignment from Friday. Yep.